Hello, my dear class 7 children. Today we are going to start with our chapter 6 sound. So let us begin. We have already learned about sound energy in our previous chapter. Brief discussion was done. So let us learn in details. If you close your eyes and listen quietly for a minute, you will hear different kinds of sound, right? Some sounds are loud, maybe the sound uh, is soft, some sounds are harsh, and so on. Some sounds are like music to our ears, they are pleasant sounds, we like hearing them. Some sounds are very noisy, they are actually noise. Okay? So, sound is a form of energy. Have you ever wondered that how sound is produced? If you keep a finger on your throat and hum, you can hear a sound. See, you will feel a vibration. Now, if you hold a rubber band between your finger and stretch, then pluck it, it makes a humming sound. So, vibration is felt. Even if you pluck a guitar string, then also you will feel a vibration. Sound is produced by this vibration. An object vibrates when it moves back and forth about a fixed point. See, in figure 6.1, a vibrating ruler is given. That is, when the ruler is plucked, it moves up and down. Vibrating objects make the air or the material next to it vibrate as well. The vibrations are transmitted through air in all directions. Sound can also travel through other materials like stone, water, and wood. We hear the sounds when the vibrating air hits our eardrums. So, what is the process? The object vibrates, air around it vibrates, and then our eardrum vibrates. This vibration is converted into nervous signals and sent to the brain by the nerve which is connected between our ears and our brain. We can recognize those sounds then. As sound travels further from the object, it becomes weaker. So, more near you go to the source of sound, you will hear louder the sound, and the far away you will go, you will hear the sound little bit less. Now we will come to the sources of sound. Any vibrating body is a source of sound. For example, a loudspeaker, a mobile phone, a whistle, and plucking of a rubber band. All these are vibrating bodies, so these produce sound. How is a loudspeaker a vibrating body? If you look closely to a loudspeaker, you will see that its membrane is vibrating, it is moving to and fro, and thus sound is being produced. Different musical instruments produce sound due to vibration. For example, the string instruments like guitar, violin, sitar, and piano produce sound by vibrations of the stretched strings. In wind instruments like flute and shehnai, sound is produced by vibration of columns as the air is made to vibrate by blowing across a hole. In percussion instruments like tabla, gong, and cymbals, they are struck or shaken to produce sound, because the membrane will vibrate and the sound will be produced. Thus, musical instruments' different parts are vibrating to produce the sounds. It is not necessary that you should see the objects vibrate. For example, when you strike a tuning fork, this is a tuning fork, it is a U-shaped fork. This is found in physics laboratory in order to test the frequency of the sound. These are the two prongs, these two hands of the tuning fork are the two prongs. For example, when you strike a tuning fork, you will not see it vibrate, but you will hear the sound. But if you touch water in a container with a vibrating tuning fork, you will notice water splashing out. If this tuning fork is hit hard against a rubber pad and then brought near a water surface, then you will see that the water surface is also vibrating. Let me show you the example. If you see this video, you will see that how water reacts to the sound waves. Amazing, isn't it? Next we come to waves. You have seen the waves in a sea or lakes which come towards the shore. You would expect a boat out in the sea to be carried to the shore, but this does not happen. The boat bobs up and down in its place. See in figure 6.4, the boat moves up and down in its place, but it does not move to the shore. This happens because the water does not move towards the shore. Alright, what moves up and down is the particles there, the water particles, they only move up and down. So we can say that a wave is a disturbance that carries energy without the transfer of matter. The matter is not moving from its place. Only a type of energy is being carried from one place to another. You can try this out with the help of a paper boat and disturb the water by throwing a stone. You will see that the paper boat is going to move up and down in its place. Okay, so let us check this activity once in order to understand how wave is a type of energy which does not move the matter. See, what we require is a chair, a ribbon and a rope. Procedure: tie the ribbon in the middle of the rope and tie it to the chair. So ribbon has been tied to the middle of the rope and the rope has been tied to the chair. Now we will move the rope up and down as shown in figure A. Here the rope, we are just moving up once and then down. A disturbance is going to travel down the rope in a wave-like pattern to the chair, but the ribbon will not move from its position. So what do we conclude? Energy has traveled down the rope, although the matter, which is the ribbon, has not moved from its position within the rope. A wave is able to transmit energy without transferring the matter. So now we will learn the two types of waves. First is transverse waves. In the activity, as we have seen just now, we moved our hand up and down, but the wave traveled horizontally. Horizontally means in this direction. Alright. See in figure 6.5 also, when the hand is moving up and down, the wave is traveling in this direction horizontally. Such a wave is called a transverse wave. In a transverse wave, the direction in which the wave travels is perpendicular to the direction of the disturbance. The disturbance is up once and then down, so up and down, but the wave is moving in horizontal direction. So this is a 90 degree, as you can see. So this type of wave is known as transverse waves. Now let us move to longitudinal waves. The other type of waves are longitudinal waves. In this wave, the wave travels in the same direction as the disturbance. The direction of the wave and the direction of the disturbance will be same. Longitudinal waves can be seen in a slinky toy or a spring. If you ask a friend to hold one end of the spring and push and pull the other end quickly, you will see the regions where the coils of the springs are squeezed or compressed, and regions where it is stretched or spread out, move through the length of the spring. See, some areas will be compressed and some areas will be spread out. The regions of a longitudinal waves where it is compressed is known as the compressions, and the areas where it is stretched is known as rarefactions. This in detail we will learn in our next class, how longitudinal waves are actually happening in our real life. So let it be till here. I hope you have understood, children. Please go through the book, read each and every line, and we will discuss with the question answers in the next class also. Okay? Thank you, class.